Well, thanks a lot for coming out, and thanks to Alexi for organizing this, and thanks to Eiley and the IBMers for helping us with all of the organization. So we're coming from San Francisco, so it was great to be able to come out to New York. I got to see the sites and really got to meet a lot of great people while I'm here. So this has just been a great experience. So thanks to everyone for having me. Just to, just a couple of logistic details. This is the network and this is the login. Would you like to? Oh, no, that.
For you.
Oh, okay. Cool. Okay. Can you guys hear me okay? Okay, great. I might try to set the mic down because I have to do a lot of typing. So let me know if you guys can hear or if I need to speak up. But yeah, I kind of, if I had a thing to attach, it might be a little easier to type. But okay, so so this is the network details here. This is red square is the network, Kaplan, and welcome. The course materials are here. Has everybody been able to get online and download the course materials? Okay, great. And then I just want to jump. To the getting started slide, just to make sure everybody's on the page with that. I can do a little bit of talking while you guys get all this set up, so there's no hurry. But how is everybody doing with Java? Has everybody got Java 8 working? Yeah. Okay. Has everybody been able to run Spark Shell? Get Spark Shell. Okay. And if you type SC, you get a Spark context. Okay. Good, good. Okay, great. So then you should be able to run the examples based on that. If you download, there's a directory called code examples, and all of the examples should just run. You just type load in the case of the Scala codes, and they should just run. So while we're getting all of that running, I'll go ahead and talk a little bit about IBM's commitment to Apache Spark. So IBM got into Apache Spark about 2 years ago. Their big contribution was the SparkSQL. They brought in a lot of people from their DB2 teams and big SQL teams to work on the SQL engine that is in Spark. They also did a lot of contributions in the MLlib. So they were the #1 contributors to SparkSQL, and then I think the #2 contributors for MLlib, and so they really made a huge commitment to it because of, as Alexi said, because of all the products that they wanted to build on top of it. They quickly realized that this was going to be really the next generation framework for big data. In the same way, this was modeled after IBM's Linux Technology Center, and at that time, Linux was not necessarily the standard operating system. And it became sort of the de facto standard, and so once we saw IBM's commitment to Spark, we realized that it was going to become one of these standard frameworks for big data processing. So it's really worth learning if you have a little bit of time to spend on learning it, because it will be useful everywhere. Just about me, I started out as a computational biophysicist. And even before that, I was a chemical engineer. So gradually migrated through the high performance computing space into the informatics space, and then finally into the big data space, where people could pay their bills. And so it's been great. It's been a great journey for me. Today we'll just talk about what is Spark. We're going to learn a little bit of Scala. Just to show of hands, how many people are familiar with Scala? Okay, good. How many people are familiar with Spark, Apache Spark? Okay. And how many Python programmers do we have? Mostly Python, and then how about Java? Okay, so a good mix. One way I like to think about Scala is it's somewhere between Python and Java. It's all, it works on the Java virtual machine, but it has a lot of the elegance that Python has in terms of ease of reading and writing, and it actually has, I think, a few more features that make it an even better language to write in. So back to the getting started slide. How's everybody doing on this? Good? Okay. Yeah. Feel free to raise your hands if you have any questions on getting this part going. Again, the trickiest part is getting Java working. So if you can get that working, the rest of it should be pretty straightforward. So, so we'll talk a little bit about what Spark is. It's basically again, how many people have heard of Apache Spark? I don't think I asked that question. Okay, so this is even new, a new idea to a lot of you. So it's basically a cluster computing framework for large-scale data analysis, which gives you parallel. The idea is that Spark is the go-to code for running analyses on something that requires more than one computer. So as soon as you're in that space, you're dealing with clusters, and you're dealing with you'll be more than likely dealing with Spark. If you're familiar with the Hadoop world, there were some limitations to MapReduce because it was not able to do in-memory processing. It also it was very disk dependent on all of its operations. You would do a MapReduce job, you'd have to load from disk, run the MapReduce job, and then write to disk, and then run another job, and then this whole sequence of events became very slow because you had all this disk I/O that was happening in between these jobs. Spark solved a lot of those technical issues, and in fact, they're so well solved that it's almost a legacy concern at this point. The other thing that's really great about it is it's comprehensive. It's got a lot of great libraries, and so you can try out a lot of things once you have it installed. You can try out, a graph library and then turn around and run SQL on it, and then do some other machine learning processing in a way that you really can't with any other big data framework. So it allows you to do a lot of exploratory things that you may not be able to do because of the barrier to entry for getting all of your code up and running. So that part is really great. It's got some very easy to use APIs. Python, Scala, and Java are the main ones. We strongly urge you to learn it in Scala, and for those of you starting a team or starting a project, we urge you really to start the project in Scala, because it will, as soon as you hit a difficulty in the code, you can always, you'll have more luck rewriting it in Scala because it's the native language of Spark. So it's worth it to spend a little time learning how to write in Scala. Now, having said that, Python APIs are really great. It gives you access to, you can run NumPy and Matplotlib and plot all of those things while you're running Spark. And it's getting easier and easier to install PySpark these days. I think you can do it through Conda. So PySpark is also a very low barrier to entry. But in terms of when you start to deal with the production workloads, Scala is probably the way to go, even more so than Java if you're used to coding in Java. So for the Java programmers, it's probably worth it to spend a few days getting familiar with the syntax. It's written in Scala, and it runs on a JVM. So all of the nuances of running Java can be understood when you're running Scala as well. So Spark is, it's open source. It does in-memory processing, which is a huge advantage for iterative processes. So when you're solving these objective functions for machine learning, you're repeatedly accessing the same objective function, which requires sort of a fast in-memory access. And that was really the driving force for the development of Spark. It gives you distributed data processing. So once you write it on your laptop, with your small file, you can write it on your cluster for your terabytes size file, and the scale up is pretty transparent. So it's a great framework for these reasons. Now, how many people? I mentioned some of the MapReduce issues. How many people are familiar with MapReduce, written MapReduce code? Okay. So yeah, it's getting to be these days. If you haven't done MapReduce, it's likely that your first exposure to big data is Spark at this point, but this was not the case just a few years back. So it's really become the standard. but just to compare what was happening, and I mentioned this before, you read and you run through an iteration, and you're always disk bound on all of these operations. And the resilience in the Hadoop file system is you have data stored in triplicates, usually in triplicates across your cluster. So the resilience is at the file system level, but if something crashes in the middle of your iteration, you have to start all the way back from zero. So Spark takes that one step further, so it can store a very complex series of operations, and you don't need to have this intermediate write state, because what it does is it stores the series of transformations that take place. I do need to take this with me if I'm going to walk over here, huh? It stores a series of transformations that take place when you go from the input all the way to the point where you're going to be writing the file or summarizing it, and it can recover the entire series of operations if one of the nodes goes down. So it stores this thing called a resilient distributed data set, which is basically a series of actions that start at load time and then goes through that transformation. So if your process goes down, it can reconstruct the entire process. So that allows you to have a much longer chain, a much longer execution plan, and still have fault tolerance. So that was really the big design advance when Apache Spark first came out. So this started out at UC Berkeley in 2009. Again, this is basically it was thought of as the next generation MapReduce. It was open sourced in 2010. IBM jumped in around 2015. Now it's a sort of a 2.0 software release. So a good portion of the code has really become hardened and optimized, but then there's still new features that are coming out. Particularly the streaming is really taking off these days. So the nice thing you can do with Spark is it gives you this sort of interactivity with your open Spark context. You can do iterative machine learning. You've got access to a streaming library. Virtually all data sources are supported now. This was a really big advance leading up to the 2.0 release. It's used by data scientists, and it's also used by data engineers. And this is one of those frameworks that may actually change the nature of how we understand what a data engineer and a data scientist does, because it all happens in one code base, whereas maybe previous versions of code had a data scientist developing it on a laptop scale, then handing it off to an engineer who would scale it up. And so it was a little more stovepiped, and maybe there was some lossiness in the way the algorithms were scaled up or the way they're interpreted. Spark can sort of all happen in one place. A data scientist, a person with a machine learning and data science background, can work with the same code base that the data engineer is also where he or she is working on production quality issues. So once you learn this syntax, especially if you learn Scala, they can all sort of work on the same code base. So I wanted to jump in and do a kind of a Scala primer, and this is Scala is a very, very deep subject, and really what I just want to try and cover is, get you familiar with the syntax enough to run Scala, to run Spark code, and be able to write Spark jobs. So I won't go into too much detail about a lot of the real fancy stuff in Scala, but definitely get you familiar with expressions and lambda expressions and how to read and write this code. So, the main reason we're advocating Scala is because Apache Spark is written completely in Scala. So if you're going to write a library, you may as well write it in the same language that the code is written in. For example, the Python API, you actually have to write separate connectors to the methods and actually expose these methods to the Python API. So the Python and even the Java API will lag behind the full functionality of the Apache Spark release. So the code is really pretty easy to read, and it's still statically typed. So this strongly typed notion is something that you see in Java. It really shines in Scala as well. My personal favorite is that it just naturally has this REPL environment. You can open up a Scala shell and import all of your Java libraries, test things out, do it all from the command line. Don't necessarily need to set up an IDE. You certainly can, but you don't necessarily need to. So type safety will allow for compile time error handling rather than runtime error handling. And I'll show you some examples of that. But once you start to get a handle on the power of type safety in good coding practices, you really come to appreciate using a strongly typed language. And the other thing that Scala has is it has thread safety baked into the syntax. That means as long as you write the sort of standard Spark code or standard Scala code, all of the parallelization issues can be handled transparently. So you don't necessarily write for loops, because for loops could have, I equals 1 to 10 on different nodes, and you could have different, those could be happening at different speeds, and it could introduce parallelization issues. Scala is written in such a way that you don't necessarily need to worry about all of these iteration issues. And they have a notion of the iterable that we'll talk about a little bit. I need to grab a glass of water, excuse me. So the origins of Scala was really to try to make a better version of Java. And so we actually had Martin Oderski's son, Jakob, working at Spark Technology Center with us for a while. So we had a lot of really deep Scala expertise for many years. And he was originally writing Java compilers. So really he came from a Java-centric world. He just really wanted to make something that was much easier to read and write. And so around 2011, the company called TypeSafe, which is now Lightbend, was founded. And today I think it's Scala 2.12 running on Java 8. Tomorrow it will run on Java 9, and that's, I think, more true for Spark. Have to double check on these versions. The entry point into Scala is this read, evaluate, print loop. It's called a REPL, and this is just a command prompt that allows you to explore the variables. The great thing about it is it has tab autocomplete. So if you guys have opened a Spark shell, you'll be able to define variables and do tab autocomplete, and that'll tell you all the methods that are available to it. So we'll do our first example, and the way this is structured is I'll have a snippet of code that I post up here that you can take a peek at. Then I'll have the name of the file, and then you should be able to go to your code examples directory and open up that file and be able to run snippets of code from it. So this simple examples has a whole list of little snippets, and so typically what I do is I open up a text editor and I just copy it and paste it into the shell prompt. You can copy multi-lines and run it that way. If you don't have a text editor that supports Scala syntax, there's one called Sublime. You can try downloading that one. I have a tar file that has bindings for Scala syntax, so let me know if you want to try to get that working. There's plenty of other text editors that support Scala syntax. We'll talk a little bit. The first sort of basic idea let's do this. Okay. Okay, so we'll just walk through the examples. I'm just going to do a couple of cut and pastes. we don't. We're just gonna go through. Can everybody? Whoa. Okay. If you see me typing and you still see a slide up there, ping me, because I have to get out of presentation mode to bring up the terminal, and sometimes I don't realize that I do that. Okay, so you can define, this is just to show you what immutability is. Okay, so when you define it, it'll say this is a little bit bigger. It's going to say this is a you defined this thing. It's a string. So it says, okay, val hello equals, and then string, and it says, oh, you said hello colon, and then it gives you the type. It's a string, and then it just tells you what the value is. The only thing that this example is supposed to convey is that you can't modify. Oh, yeah. So you can't modify it in place, but you can, which just means once you define it, it's immutable, and this allows the parallel construct to hold up. And so the thing to remember is that when all of the parallel constructs in Spark are immutable, so try to stay immutable for most of your code, and most of the Spark code will sort of hem you into doing only immutable operations. But you can do this var, which allows you to let's see. Yeah. So now you can append to that string in place with if you do var. So if you need to iterate through something, but you can see why that the immutable thing is if you wanted to do an I++ as you're iterating through a loop, and this is happening on different machines and it's happening at different speeds. It's harder for it to keep track of that. So there's actually a special construct for doing that. Okay. So I'm just going to go through some of these expressions. This one here, it says, so an expression is basically, think of an expression as something, typically you put it in curly brackets, right? So you could put this in, since this is one line, you don't have to put it in curly brackets, but an expression can, it's actually a more general form because there's kind of this ambiguity between what a variable and what a function is in a functional language. So it really is contained in this notion of an expression. So here everything is covered in this definition, but sometimes if you have a variable that's not defined in the expression, it'll return a function. So you say, this. So for example, if A, hello, else goodbye, then that would return a function of A, which would allow you to pass in a Boolean value, and then if it's true, it would say hello. If it was false, it would say goodbye. So that's actually this lambda expression here, right? So you've got val coming or going, and now this is this is a fundamental idea in Scala that makes it a functional language, is that you have a variable, and then this forward arrow means that it's a function. So this is a lambda expression, and so now what this is saying is saying this is a function of n. That function of n is if n equals 1, hello, else, goodbye, right? So all you're doing is taking what was an expression and not defining it completely, and saying, oh, now it's an expression, but it's a function of n, right? Now you pass in this value of n, and you get a value. And so, but it still treats it as a val, right? So this is a notion in functional program where they say functions are first-class citizens, right? You can pass in a function in the same way that you would pass in a variable, right? So there are other things you can do with expressions, right? If you have multi-line expressions, then you start to do the curly bracket thing. And the other thing to remember about expressions is the last line, whatever's in the last line is returned as an output. So, so you could actually put return here, like you would in Python or something like that, and then it kind of looks like a function, right? But again, this is something that we think of as an expression. So, and a lot of times when you have multi-line expressions, it's always good to put the curly brackets around it. Sometimes the command line, it helps the command line editors to see what's going on. But so we can run a. Let's see, how are we doing for time? 2, we're doing okay. Yeah, we'll jump into the strong typing real quick. The talk last night, I just tossed this example in last night because the talk was, this was the x.ai, and they were saying one of the strengths of the Scala language is a strong typing partially because they have so many possibilities they have to scroll through with these chatbots, right? They have if this then that, if this then that, lots of case statements and things like that, and you may not be clear if you've covered all of the possibilities when you're writing the code. So when you do strong typing, what it will do. Let's go to this one because this one's kind of an interesting one. This poorly typed expression will say, is saying, if it's true, return a 1. But it doesn't say what to return if it's false, right? So it gives you this type called anyval, which is not exactly what you want. You want an integer, right, as your return value. So example, what you really want to do is you can enforce this typing by saying, okay, I know, let's say I covered all my cases. I'm going to get an integer in every case. So I expect to see an integer returned, right? So it's saying, wait a minute, no, you didn't cover all your bases, right? You missed a spot. It's this type that's different than what you thought you were going to get. And what's nice about that is this type checking happens before you load your terabyte data set, right? Before you commit to running all of this massive amounts of code. So this really will save you a lot of time if you start to get the hang of how to do the typing. So yeah, you don't have to specify the type in the definition, but when you do, it becomes very, very helpful. All this stuff happens in the IDE too. So once you get your IDE set up, all this typing will happen not only at compile time, it'll just be happening while you're editing. So if you're familiar with the Java typing, it works in a similar way. Okay, so we'll talk a bit about methods. There's nothing too terribly exotic about the way methods are defined in Scala, but they start with a def statement. That way, you're saying, well, this is a function or a method here. It allows you to pass in defaults. So let's do. So once you do it, it'll create this method. Now this is not a val. This is actually treats it as a function, and it allows you to just do some defaults. So if you just do, let's see, name, it'll return first and last if you don't do anything. The thing I like about this too is you can say what variable you're specifying. So it allows you to do it gives you a little bit of clarity when you're defining your functions. So this is the kind of things you can do. You can say first equals this, last equals that. That way you know which variables you're passing in, makes it a little bit more readable. There's this notion of this is kind of a unique construct to think about. Again, I'm not going too deeply into the object-oriented stuff because you don't necessarily, at least when you're starting to write your code, you're not going to be dealing with object-oriented issues as much. As the code base gets larger, clearly you will. But this one will show up when you actually commit to compiling your Scala code, because you need to create a singleton object in order to compile it. That's like the main object. And so a singleton object is just something that has one instance, so you don't need to, once you define it, you just refer to it, that the name, you can refer to it by name. Oh yeah, and don't forget that it has the autocomplete, so it'll tell you what fields are available there. This is a way you would define a class. I'm just going to talk about this one. Again, it's just pretty compact, right? I mean, if you look at creating a class with fields in Java, it's going to take you 10 lines or something like that, or 5 lines or something like that. This one here is all it's a one-line type of operation. This one this one here actually shows up a lot. So this one is worth thinking about a little bit in Spark, just so you understand. One, because I think the nomenclature is a little confusing as to how it, what it conveys in terms of its intent and what it actually does, at least in Spark. And what it does in Spark is it creates a container for different variables of different types. And so so you have a case class here. And let's just go ahead and define that. Okay, so you created your case class, and now you got test, and then now the fields that are available. These are all these kind of methods that come built in to a case class, but in there is message. So you can create, you do a case class and you say, okay, the first field is message, the second field is something else that's an integer, something else that's a float, and you basically create something that can contain multiple types in a way that you can scroll through. And that's useful in Spark because you create something called a data set or even a data frame that where it's essentially a table and each column has a different type. So this is what you'll see in Spark when you're defining these multiple types. These rows that have the possibility of having multiple types. So yeah, just keep an eye out for this one. This is people like to use this one because it's compact and elegant way to define all of your different fields. But you'll see this, even before you even get to the object-oriented stage of your development, you'll see case classes in your script level code. Not going to go into companion objects. You don't see them as much. I'll talk. How are we doing for time? I'll talk a little bit about the something called the simple build tool. So Maven does work for Scala. How many people are familiar with Maven? Okay. Okay, so Maven works for Scala. In fact, Maven is now the preferred build tool for Spark. It's the recommended build tool for Spark. Simple build tool is still the recommended build tool for Scala-centric code. So you can use both. SBT has a few nice features. All the examples today I've designed to run just from the REPL. So just in the interest of time, we didn't get into how to run compiled code and do build codes. But I do want to point to a few really neat things about SBT. It also has So at build time, you can invoke a console, and you bring up the console, and then you can do exploratory analysis of your variables through the command line. And in fact, when you open up Spark Shell, what you're looking at is an SBT instance where they invoke the console. So they loaded all Spark libraries for you, and then they said, hey, bring up the console, and then you can do exploratory analysis on it. And it also has continuous compilation, so you can have this running while you're editing your code. It doesn't necessarily have to be in an IDE, but while you're writing your code, it will debug your code and tell you what's going on, and you can modify your code that way. So yeah, it's the native compiler for Scala, and it's worth checking out. I actually prefer it over Maven. So the concept of a collection in Scala is it's a pretty fundamental idea. It's worth trying to get your head around, because even writing the simple RDD-based Spark code, you're going to be doing these operations on collections. And I know this is all it's kind of hard to read, but the top there is a notion of a traversable, and then right under that is an iterable, and then it branches out into all these other types that are based on that. But the notion of a traversable is really, just the traversable and iterable really kind of tell you what the idea behind a collection in Scala. So this, it's a 1D list of items, and there's some recipe for traversing that list or iterating through that list. That means, again, it's designed with scalability in mind. So if you say you don't say for I equals 1 to 10, add 1 to each element. You say .map x forward arrow x plus 1, which just means that apply this function to this list of variables following this recipe for iterating through the collection that is predefined, that is already understood. So you say, I don't care what order you add x plus 1. I don't care if you do it in blocks or how you do it. Just iterate through it in the way the iterable specifies. So that allows you to go through these collections in kind of an automated way without having to worry about parallelization issues. So when you write your code on that runs on a single thread or a single CPU, and you scale it out, all those parallelization issues are kind of handled under the covers. So that's the main idea behind most of this the way collections are designed in Scala. And so let's see. Yeah. So just to show you what some of the basic operations on collections that you can do. I guess the first thing that was confusing to me when I first started to learn Scala is that a tuple is the one thing that's not a collection. A tuple is just basically kind of you just stick a bunch of stuff together and that's your tuple. So it's kind of like a case class actually, right? But here it's just a parentheses, and you can access it by element, but it's actually, the access model looks very different. It starts at _1. Let's go ahead and run those so we can get a feel for how these look. Okay, so when you define it, it figures out that it's a type. It figures out that the first element is an integer, the second element is a string, and then you just access it. And if you look at the methods that are available to it, it says, oh, I can get the _1 part of it. I can get the _2 part of it. So that's actually thought of as a method in this type. And it also, for the 2-element tuple, it looks like something called a key value pair. And a key value pair is something, again, if you're coming from the MapReduce world, the key value construct is something that you see over and over again when you're doing word counts, for example. So that's just an example of what a tuple is. But the important thing is that there's no recipe for iterating over a tuple, because it doesn't know that the first type is going to be an integer de novo and the second type is going to be a string. So there's no clever tricks that you can possibly apply really to iterate through that. So they just say, okay, we'll just give you an access model for accessing each element, and that's how that's set up. So you can do you do something like maps. Maps are iterable, and you can do things like union operations. So let's just take a quick look at what that looks like. This is so you have. Okay, so it's an immutable map. Oh, yeah, thank you. No problem. All right, yeah, let's try that again. Okay, so define map 1, and then we define map 2. Is everybody able to run these examples? The idea was to kind of run them and kind of interact with them and see what they're doing. And then you can do this union operation. So now you can look, and then it just puts those together. But you can look at the methods that are available to a map. They're very different than what's available to a tuple. So you've got things like zip, toArray, collect, which is interesting. Filter. You can do all these other stuff to these collections once it gets into once it becomes an iterable that you can't do with tuples. So I think so let's just take a look at some of the stuff you can do with collections. And this is really when you're noodling out the syntax, you can end up writing a very complex iteration in one line of Scala code. But that line of Scala code may take you a long time to write, because you got to figure out the syntax, and it still takes the amount of time that you write a 20 or 30 line double or triple for loop, and it takes a while to write it. It'll be very compact, but it'll still take a while to write it because you have to make sure it's right. So that's why having that command line to kind of noodle through the syntax, because the syntax can trip you up for a while. So the first thing that's done here is you create this range. So 1 to 5. This is very similar to the Python way of building ranges. And then now we're doing this lambda expression here. So we're saying 1 to 5 map, and then again n, a function of n, which is n plus 1. That's the lambda expression. So before I do that, does anybody know what that's going to be, or anybody? Yeah, it's 1 to each element. So that one is pretty straightforward. Good. And it just gives you 2 to 6, right? And then there's a shorthand here. There are lots of shorthands in Scala. I try not to cover too many of them because it's already hard enough to get your head around the basic syntax. But you'll see this one a lot, where you just replace this whole lambda part here with this plus equals 1. And so that's essentially, that'll return exactly the same value. Now this is really cool. If this lambda expression gets complicated, then you just define a function and replace that with the function, right? So again, here we're defining a new function as a val, which we can do because it's a functional language. And so now we go add 1, that gives you 2, right? Now we're going to just do, and this is kind of a nice, a little bit cleaner way to do it, right? You can, again, you define your function inline or have a method or something, and then just do this map, and then as the functions get more complicated, that improves the readability. So yeah, here's just another, starting to get a feel for what would happen if you wanted to get a little add some vector of strings or create a vector of strings or something like that. Now the reduce operation is again this takes two values and returns one value, and so you're going to add one to it, and a reduce operation means take two values, return one value, and what this does is it assumes that it doesn't matter what order you add these in, right? Or what if you add groups together, and if those groups add, and so you can always have this, in goes two values, out comes one value, and so the syntax here is this tuple of a comma b, lambda expression a plus b, and so basically now we're going to take that array 2 to 6, and then we're going to add up all those numbers. So you'll see this. Okay, it returns an integer. And this is another piece of syntactic sugar here that you'll see a lot, is this underscore plus underscore. And this doesn't necessarily have to be an addition operation, or although 90% of the time it is. It could be multiplication operation. It doesn't have to be integers that are adding. You can append strings, anything that takes two values and returns one value. So here's one where it reduces the strings. Again, yeah, so it just turns out that the plus operation is recognized as an append for strings. So we'll so actually in this one here, the order can matter. So there are places where you want to exercise caution with that, there's things called fold left and fold right and all these other operations as you get deeper into it that'll become apparent and more interesting, but the basics are covered here. And filter is another one that you'll see a lot. And all this does is now this lambda expression is something that has to return a Boolean. So anything that meets a criterion x is greater than 2, or it returns true, is going to be retained in the collection. So we'll do that one. And 3, 4, and 5. Okay. Okay, so here's just a simple example of processing a collection. Create a range 1 to 5,000, filter out those that are greater than 400. Take 5 would be take the top 5 elements and then print out the results. And so we actually wrote this as an expression just because it's a multi-line. It can now be a multi-line expression. Sometimes it doesn't figure out if you don't put the dot in this line here, it will think that maybe that's a standalone expression. So if you put in curly brackets, it knows that it has to go through the entire session. So do that, and that gives you 401 to 405. Was that sort of what you expected for that? Does that make sense? Okay. All right. And I think this is the same one. Yes, that's the same one. The only thing that I wanted to show here is that you don't have to put the periods in between the methods. So if you like this syntax, some people do, some people don't. You can just put a space in between the methods. And so this is exactly the same method as that one is. It's just got spaces there, and it returns the same result. People tend to like this because you can. It looks a little bit more like a like a domain-specific language or something like that. But either is fine. So let's see. We've got yeah, we can talk a little bit about creating more complex collections. Figure we got just a couple more examples, then we'll take a quick break, get some air, and then we'll jump into Spark examples after the break. Does that sound good for everybody? Yep. Okay. Okay. So. Yeah. So I thought I might skip this one. This might not be working. So yeah, we'll jump back to this one later. I'll just talk about this one rather than noodling through it. So the way you can build if you think of like you're writing in a procedural language, you would iterate, you would say, for 1 to 4, for x is 1 to 4, for y equals 1 to 4, you're going to do this x-y combination, right? And that's going to go, 1 1 1 2 1 3 1 1 4 2 2 2 3, right? This is the procedural way of doing it. Now, what's not recommended in Scala is to do this through an array that you update in a mutable way, right? You create an array with all zeros, and then you update the particular entries with new values as you iterate through the loop. That would be like the Fortran way, right? And that's because the types are immutable, right? So you can do it recursively by just basically giving a series of instructions and having to do this kind of a for each operation where you go through. You're doing it recursively, so you're not actually, all of the instructions are being built up in the stack, and then it's sending all the, once the recursion is done, then it sends all those instructions and builds a single immutable array one time based on all the stuff that's on the stack. Probably not the best way to do it, particularly in Spark, because the recursion stack gets very, very large because you're carrying all kinds of other stuff in the instruction set in addition to just the simple recursion. So it can very quickly blow out your memory, and you have to adjust your memory in order to get it to work correctly. So probably the best way to do it is to try to think in these maps rather than iterations, and then so you can do something like this, where basically now you're saying map x is 1 to from x go from 1 to 4, and then do another map, and then y equals. Now you've got the x, y, get the matrix entry, and then flatten that into an array. So really, I mean, the take home here is just to try to think of, instead of for loops, think in terms of maps, and a lot of the parallelization issues will be handled transparently. So let's see, what's that one look like? Did that one? No, a lot of this stuff is something's goofy with it, so we'll come back to it. Yeah, have to come back on take a look at that example. But okay, so these are here's some further reading. There's an O'Reilly book. Dean Wampler wrote a great O'Reilly book, and then this is written by Martin Odersky. I would say this is more of the Java-centric person. A lot of detail, but they're both great. They both cover actually the Java side of it very comprehensively as well. My personal favorite Scala site, and the one that really got me calibrated to Scala syntax, was this one here. It's called I don't know if you can see it or not. It's called Scala 99 Scala problems, and it's just a lot of a lot of really cool reversing lists and doing all of this other kind of stuff. I think he actually wrote a few games in it, graph searches, and all kinds of cool stuff, and it really gives you a feel for what you can do with Scala, and all the syntax nuances. So that's it for Scala. We're about an hour and a half into it, so I can answer any questions at this time. If not, we can take a little break. Okay, great. Yeah, feel free to come grab me if you have questions too. So we'll take a 5-10 minute break. I'll just kind of hang around. We'll convene.